Well, thank you for that introduction, and thank you, Steve, and the TEDx organizing committee, and thank you all for coming here and listening to what we are believing it's a grand idea. Let me start by saying that I'm a marine biologist by training, actually a scientist, turned businessman by vocation. And I have the privilege of traveling all over the world. And I do know a little bit about food production in many different countries, in many different industrial realities. And one of the things that gets me going is to think about sustainability in these food production systems. Well, that's something that I share with Novus. And at Novus, we like to innovate. And one of our craziest innovations lately has been what's called as aquaponics. You may think of aquaponics as a system that produces fish and vegetables in the same closed, confined quarters. As a scientist, the first thing I did was deal with the technology. Well, that took some time, and after that, the businessman in me kicked in. And so, how can I make this business profitable? How can I make it more capital efficient? And I found myself answering these questions that any business needs to answer in the same orthodox way that food production has been answering them in the last 150 years. I got to make it bigger. How big do I need to make my business in order to be profitable? Well, that is natural, because if you think of it, that's the way food production has evolved. You see, egg production today, it's a massive scaled-up business, a linear scalability, actually. We are producing large amounts of one single crop or one single animal, and we're producing it very efficiently. It has brought us, mankind, enormous advantages. We have enormous economies of scale in food production today that we did not have 50 years ago. On average, each one of you is spending less than half of the income that your parents were spending on food. Think of it. That's a great achievement. But did it come without disadvantages? You know, my environmentalist friends, and being part of the industry, it's rare that I have environmentalist friends, but I do have them. They are saying some things that are very sensible, and we need to look at them. You know, let's look at the problem of dissociation of cost and price, because once you commoditize food, food becomes a commodity, price stops being associated exclusively with cost of production. This is what's been happening in Africa, where in spite of all this scalability solving famine all over the world, it's also causing famine in some of the food crises. Perhaps even more telling that the blanket is not large enough to cover the whole of us, is the fact that we're dissociating price of food with value of food. You know, some of these countries, the ones that are developed, the ones that have money to spend on food, the US might be the prime example of it. In some of these countries, a burger costs less than a lettuce. Does this make sense to you? It should not. In these countries, in these cities, sometimes it's even hardly affordable to get any seafood at all. What will happen to the lower income population of these cities if this quality food, if this healthy food stops being available? I guess obesity is a natural consequence of our models. So this question of linear scalability, this question of having a system that goes from producer to consumer in a linear fashion, does it bring environmental problems? Of course it does. It was depicted out of the mining industry, post-industrial revolution world. We are producing food the same way that Britain organized the extraction of coal, the bigger, the more, from one single spot. But when you extract coal, the more of it, you're going to end up with a big hole in the ground. That's pretty much it. But an ecosystem, the one from where your food derives from, it's not a coal. It's not an extractive system, it's a reactive system. If you take a lot of one single thing out, you're going to have to put a lot of one single thing in. And this causes environmental problems, huge environmental problems. So, is this the linear scalability? Is this the only model that we have for ourselves? If you think of nature, nature is not linear scalable. And in fact, scalability in nature is not about size. It's even not about making it an orderly fashion. Scalability in nature is about numbers. It's about connectivity. If you think of an ecosystem, and that pink picture is the graphical depiction of an ecosystem, You know? Does that shape look familiar to you? It should, because this is a geometry that it's all around us. It's called fractal geometry, but it's the geometry of nature. It's a geometry where it matters is connectivity. For nature, it does not matter if the chicken came before the egg or vice versa. What matters is to connect the chicken with the egg, with the water, with the insects, with the grass, and with everything that it's all around it. It's a geometry that it's widespread, very present. It's in your brains. It's in your immune system. You know that? It's in an ant colony. And you know why? Because it's extremely resilient. It has this wonderful mechanism of self-regulation. If you imbalance one of these systems, it will self-correct itself. And that's why it's so widespread. But it's not only found in nature. Some of our best inventions, us, mankind, have this geometry, have this nonlinear scalability. The internet being perhaps the most recent example. Nobody regulates the internet. Nobody is having conscious decisions of, oh, let's make another internet cluster. No, it grows by itself. It grows by connectivity. Cities, the economic system, stock market, all of these things are resilient in nature. We have actually less control over them than what we think. You see, it is this wonderful geometry of nature that made us think in our project that maybe we were looking at scalability the other way around. Because if it's about connectivity, how can we make these interconnected businesses work? And now, let me come full circle, because now, today, in the 21st century, we do have the technologies to do this. Do you know that we can produce wallets out of fish skin? Yeah? We can produce medicine out of algae byproducts, energy out of corn waste. We can even recycle a restaurant food waste into insect meal, convert that into crop fertilizer, and the rest into chicken feed. Think how wonderful this is. And now you ask me, but business is business. Is it profitable? And the answer that we found out is yes. Actually, they're extremely profitable. But you have to flip-flop the notion of scalability, because it's not about making it bigger. It's not about making it extremely big. It's about making it interconnected with each other. You see, what we think the next revolution in food production is going to be is the creation of local clusters of small businesses that are all interconnected and where the output of one becomes the input of other. It's not about replicating this post-industrial world revolution, a system where it's about extracting multiple enormous amounts of food from one field or from one chicken house or from one lot. It's actually about making them interconnected with each other and mimic nature's geometry. And so what we think is that there is space for large-scale food production. Of course, you know, my favorite animal is the blue whale. You know, the same way that some ecological niches in nature are going to be taken up by some very large animals, there will always be economic niches that have to be taken up in order to be efficient by very large operations. But it's not the only model. And it's certainly not the only profitable model. And it's certainly not the most profitable model. So we do think that the next step in food production, in sustainable food production, is the creation of these local clusters that interact locally and then interact regionally with each other. And hopefully, doing so, we will be able to provide some local healthy food to some of these low-income kids. Thank you very much.